Alright, chemists, so today we're going to look at the energy of chemical reactions. And we'll start off with what the signs of a chemical reaction are. Then we'll look at how energy is required to break chemical bonds. And this brings us into activation energy. And then we're going to look at enthalpy. Okay, so what are the indicators of a chemical reaction? Well, we know that a chemical reaction is one where a new substance is formed. And there are several signs. So that a gas is produced, that's happening over here. You can tell us by bubbling or a smell. There's a change in colour, or there could be a change in colour. Any one of these will do. A solid is produced, and this is called a precipitate. There's a change in temperature over here with the shuttle. There's a very definite change in temperature. That's an exothermic reaction. Light is released, again, with the shuttle. Light is being released. And you end up with the same number of each type of atom. They're just rearranged in a different way. If we look at here, the oxidation of magnesium, we see that we have reactants on the left-hand side and products on the right-hand side. Now remember, we always say this arrow means goes to. It does not ever mean equals. Okay, so let's look at the energy of bonds. So chemical reactions, they involve energy changes. This is necessary. We use energy to break the bonds, and energy is released when new bonds are formed, because it takes, for the atoms to be on their own, that means they're holding energy. So when they join back together with something, they release some of that energy. So we have energy breaking the metallic bonds down the bottom, and energy splitting the bonds in the oxygens, and basically energy is released when they join back together. Now, if energy given out by these, given out by the new bonds, is greater than the energy used to split the earlier ones up, it's an exothermic reaction. And combustion reactions like this, they're always exothermic. Now, if the energy given out by new bonds is basically less than the energy used to split the bonds apart in the first place, the reaction is endothermic every time. Electrolysis of water, that's an endothermic reaction. Now let's have a look at the opposite of that. And we see that down here with the shuttle. Here, essentially, hydrogen is being oxidated in these big tanks. So hydrogen is being added to oxygen, boom, you're launching something into space. So that's a very exothermic reaction. Now let's look at the enthalpy of that. So remember, enthalpy is the total energy change. The enthalpy of if you remember, of an exothermic reaction is always negative. So, which is a bit counterintuitive, but it is. So basically, the sum of the bond energy for the bonds broken minus the sum of the bond energy for the bonds formed, this gives us our enthalpy. Now if we have a look here, this is a hydrogen-hydrogen bond, of which we have two. This is an oxygen-to-oxygen bond, which we have one of. And this is a hydrogen-to-oxygen bond, of which we have two of in a water molecule. And we've got two water molecules, so it means we have four of them. So we do a little maths, pretty simple. We add these ones together, okay, and we minus it from that one. And this gives us our total energy change. Okay, so the bonds in the reactants and the products, the energy is a negative, which means it's no longer holding that energy, it's gone. Before you write this down, which you probably already have, and I do apologize, that needs to be not kilojoules, but kilojoules per mole. Kilojoules per mole. So you could actually work out, if you wanted to, and we might do this just for fun, how much energy, what the energy change is of adding these tanks full of hydrogen and oxygen, liquid hydrogen, liquid oxygen. We'll work that out in class, I'm sure. It'll only take us all day. Now, so what we have is we have energy changes in a reaction. If the energy is negative, so the enthalpy is negative, which means energy is given off, it's an exothermic reaction. This is the combustion, and combustion's always exothermic reactions. I want you to write this down, and I want you to write it down carefully. What I'm about to say now, is that every type of bond has a characteristic amount of energy. So hydrogen to hydrogen bonds, they hold a certain amount of energy. Oxygen to oxygen bonds, a certain amount of energy, and so forth. Okay, so activation energy. Basically, to start a reaction, you need to put some energy in to break the stable bonds. Okay, so you need to put energy into nearly every reaction to start it. Now, if the activation energy, and this is called the activation energy. So over here, we see a positive change, which means it's a endothermic reaction. Okay, so if this one here, this will do. So if it went up and then down below here, so there's less energy than when it started, we'd call that an exothermic reaction. That's it. There was a lot there, and we'll get into it in class. We'll do some calculations because I know exactly how much you love those. Sweet as. See ya.